So, the discriminant. What do you think it is? What do you think a discriminant would be? Something that discriminates. Perfect. What does discriminate mean? It kind of like means that depending on it, you'll get this, this, or this, right? So if you discriminate between people, you're putting them into groups, right? You might say, okay, we're going to discriminate on hair colour. We're going to put brown hair, not brown hair, over here. Put yourself in a group. All right, so that sort of idea that from something you will be able to tell something.
Oh, right.
Right. Okay, so what is it then? So yesterday I told you this was really important. B squared minus 4ac, which we find in the quadratic formula under the square root sign, is the discriminant. All right, we use a triangle for some reason to say what it is, but that's just a mathematical notation. So the discriminant equals b squared minus 4ac. So why do we need it? Well, when we have quadratics and we're solving, there are three things that can happen. What we're really doing is we're finding out how many roots a quadratic has, a parabola has, right? Now, a root is a solution, but it's also where a graph goes through the x-axis. Okay, so we've got three pictures we can have. We've got this one, lovely parabola. We've got this one, another lovely parabola. We've got this one, the third and most beautiful parabola. These three scenarios of parabola give us three different things. When we're solving from this one, we get two solutions. When we're solving this one, we get one solution. And when we're solving this one, we get no solutions. Now, the problem is that if we knew next year's stuff now, we would have a little bit more of a different take on this. So what we actually have when we write this is that this one has two real solutions. This one has one real solution, and this one has no real solutions. And the reason for that is it actually does have solutions. We can find solutions for it, just not in the realm of numbers that we actually know at the moment. So at the moment we're after these three categories. We want to find out what happens to give us these three categories. And the discriminant, just that one little bit that we identify first, can tell us. So for this one to be true, b squared minus 4ac has to be greater than 0. And the reason it has to be greater than 0 is when we take that plus or minus square root, the square root of that number gives us a number, and we add it and we subtract it, giving us two answers. All right? So as long as there is a positive number under our square root sign, we'll get two answers, the plus and the minus version of it. This one is when b squared minus 4ac equals 0. So what's the square root of 0? Not a trick question. 0, right? So we're adding and subtracting 0. Are we going to get different answers? No, because adding 0, subtracting 0, it's not actually changing what we've got. So we'll only get one answer out of our quadratic formula here, if b squared minus 4ac equals 0. So this one b squared minus 4ac is less than 0. So if b squared minus 4ac is less than 0, we've got a what? A negative number. Okay, so a negative under a square root sign, Amy, means what? A negative under a square root sign. Yep. Doesn't work on the calculator. A positive under a square root sign, when we're solving the square root of a positive, we're asking what number multiplied by itself gives us that. All right? When we've got a negative, what number multiplied by itself gives us a negative? There is absolutely no number, because a positive times a positive is a positive. A negative times a negative is a positive. We can't get a negative number. So if at this point we get b squared minus 4ac as a negative, we don't have to do the rest of our quadratic equation, which is why we want to do it first. All right? Because that tells us there are no answers. There are no real solutions, because b squared minus 4ac is less than 0. So that's why yesterday I said do this first. The question might go something like this. How many solutions does 4x squared minus 3x plus 8 equal to 0 have? Now you've got an option here. You can stick it in your calculator, and your calculator is actually going to tell you the answer. But you're going to get no credit for it because you haven't identified why that is so. Right? So it's a good place to check that you're right. You put this in your calculator, a equals 4, b equals negative 3, c equals 8. It'll tell you either here are the two answers, here is the one answer, or maths error or something like that. Can't do it, signifying this one. What they want to see in the algebra paper is that you understand that b squared minus 4ac with a equals 4, b equals negative 3, and c equals 8 gives you negative 3 squared minus 4 times 4 times 8 gives you 9 minus 8 times 8 is 64. And that's not 8 times 8, that's 16, 80, 104. Somebody check that for me, please. 128. So that will give us negative 100 and yeah, good. All we really care about is the fact that that number is less than 0. It does help if the number's right? So because that's less than 0, we have no real solutions. So that's an easy version of it. Here's the merit question. They like K for some reason in this question. So find K so that 2x squared minus 3kx plus 4 has two solutions. All right. So the bit that's first and foremost important is this bit here. Has two solutions, bells ring, b squared minus 4ac has to be greater than 0. So b squared minus 4ac is our discriminant, and that has to be greater than 0. So what have we got? We've got A equals 2, B equals -3, K, and C equals 4. So now we're just solving. So that part there is the beginning of it. -3k squared minus 4 times 2 times 4 needs to be greater than 0. All right, so what's -3k squared? 9k squared has to be greater than 4 times 4 is 16 times 2 is 32. So k squared needs to be greater than 32 divided by 9. So k, now here's the tricky part. The answer to k squared equal to 32 over 9 is k equals plus and minus, but yes, the square root of 32 over 9. 32, not 9. So those are the solutions to equals. But we're not trying to get equals, we're trying to get greater than. So when we have that, what we have to look at is this particular quadratic and know it's a positive quadratic. So this quadratic looks like this. All right? We need to know when that quadratic is greater than 0. So actually it's this quadratic that we're drawing, this one here. So k squared is greater than 30. So this point here is positive square root 32 over 9 over 32 over 9. Get it right. This one is negative 32 over 9. So those are our two answers. We need to know when it's greater than 0. What represents greater than 0 in that little picture? Lisa?
That little y is literally greater than 0.
Right, it's when the graph is above the line. So when is the graph above the line? When it is between these two? No. When it is less than, when k is less than negative square root 32 over 9, or when k is greater than positive 32 over 9. So that's your answer. So this is looking at a merit, getting close to excellence question, okay? All we have to be able to do is find k. K could be here, it could be here in our equation, it could be here in our equation. But we have to know the right thing that happens here. The most complicated one is always when k is with b, because we square it. So it becomes part of our quadratic. Whereas if k had been here, it would be linear, and we'd be solving our linear equation. Okay, so that's how we end up. We get our two answers. That is the answer to the question. When k is less than square root 32 over 9, which you can turn into a decimal if you want to, or when k is greater than square root 32 over 9, we will have two solutions at any point when k is bigger. So k could be, what's 30 square root 32 over 9? So if it was negative 10 or it was positive 10 in there, we're going to get two answers. If it was equal to square root 32 over 9 in there, equal to it, we're going to get these 2 points, which give us one answer. If it was between square root 32 and negative square root 32 over 9, in here, it's a negative, so we're going to get no answers. All right, we'll let that sit with you for a while.